Hey, hello friends. In the last videos, we have seen the overview of linear regression machine learning concepts, as well as we have understood the description of the machine learning problem that we are trying to solve. So in this video onwards, we will have maybe 3 or 4 videos which are going to cover the implementation part of it, right? So let's move forward with the implementation. So the first one here being, we are trying to um, we are trying to import the required libraries for this problem, right? So for data processing we have pandas and numpy. So these are the two libraries that primarily help us with respect to visualizing the data. I mean, when I say visualization, not pictorially, but at least get a first-hand impression about the data, and also a lot of operations that we do on data, whether it is mathematical operations or combining different data frames and data sets. There are a lot of such operations that these libraries help us, and very handy, and also multi-dimensional arrays. When it comes to data science, it's all about dealing with multi-dimensional data. So these two libraries are really handy with respect to that. Yeah, I think visualization, we have a couple of libraries called Seaborn and Matplotlib. So these two libraries help us to pictorially visualize different parameters, either univariate analysis, like the parameter itself we will analyze how it's spread, or multivariate or bivariate analysis, where you are trying to see that parameter in perspective with the output parameter. So these sort of visualizations from different perspectives, these libraries really helps. And then for data pre-processing, when I say pre-processing, really you might have to substitute some parameters, substitute some textual parameters with numerical values which the algorithms expects. So for these kind of things we use one hot encoder, and power transformer is one library that is really useful to scale your data to fit your data with some sort of distribution that again the algorithms expects, but we'll see them, we'll see more details down the line. Apart from that, sklearn is the actual implementer of all the machine learning models, and it also has the pre-processing libraries and model selection. In terms of model selection, it has some important objects and libraries that we might want to import. So one of them is train test split. So this is very useful to actually divide your data into training subset and testing subset. And finally, the linear regression. This is actually the main library that we will be working with for generating the model. And there's also some other variants of it called lasso, ridge, and elastic net. So these are 3 different variants which will basically optimize your model further compared to what the linear regression plain model would do. So we will see again more about it down the line. And then in order to measure the performance of a model, the efficiency of a model, there are a couple of libraries called R2 underscore score and mean squared error. So these are a couple of objects that will help us to measure the performance of the algorithm, right? And then we are disabling some implicit warnings so that it looks clean, neat and clean while we are walking through, right? So this is about the libraries. And then moving forward, here we would be actually importing the actual data, right? The CSV file, it is not included in the repository. I would provide the link of this particular notebook in the video description below, but I would not be providing the CSV file. This can be directly downloaded from Kaggle, and the link for that is actually present up here in the description. So please download from there and keep it in the location of this notebook. Then you pass that path in order to load this data, right? So the pandas library has the read CSV method which expects the CSV file, and it would prepare a data frame object, right? So data frame object is basically a kind of 2-dimensional array that is prepared from the input data. But the beauty about this data frame is it basically has for horizontally it creates some indexes, right? Indexes meaning it will have numerical indexes by default, but you can also give some other friendly labeled indexes, like for example years you can give, or month names, or you could give like a city name, for example. You have data about different cities in different rows, you could give those sort of indexes, right? So such kind of things is possible through data frame, and also vertically as well. You have column names, right? So those column names would be taken as indexes there, right? So that is how you can visualize it's a indexed and labeled multi-dimensional array. So we can not only index through numerical values, but we can index through friendly names. That is one part of it. The other important part of it, data frame is the key data structure where we will do a lot of processing with data. We do a lot of slice and dice. We select a subset. We select only a vertical one column or multiple columns. And we can select some data conditionally. There are a lot of huge set of operations that data frame provides. We'll see more of them here, and also I will do a separate video about the operations of data frame alone. But that's what we get out of this, right? A data frame is prepared. Now we want to understand the data, right? This particular method, if we call from the data frame object, this basically gives us let me execute and show you. Maybe I'll comment this line. That's not required now, right? So if I execute it now, it is just describing about our data frame. So it highlights the data type, and it is indicating how many entries are there in the range index. So if you look at it, range index is really referring to your row indexes. That means the number of rows here, right? So that would be the range index object that has 205 entries, so which indicates that you have 205 rows in this particular data frame, with indices starting from 0 to 204. And it also is highlighting the number of columns that it has, right? So we have 26 columns, and each column here, it is described in terms of how many non-null counts are there for that column. So what that means is how many values are there, and if there are any null values, then it will have a lesser number of values than the number of rows here, right? So if we have a difference like that, we will know there are some null values in that particular field, and we need to handle them if that happens. But we will see down the line how to handle them as well. And then the data type of it, right? So as you can see, there are, for all these 26 columns, it describes that perspective. And the good thing is we don't have any missing data. So all the rows here, all the columns here, they have 205 values, which is good. And also there are different types of data here, right? We have the integer data for things like car ID and symboling. And the object types typically indicate alphanumeric or textual data here. So things like fuel type, aspiration, car body, drive wheel, engine location, right? The front or rear location. These are all textual data which are actually represented as object type. And you have the float 64 data type for different continuous kind of values like wheelbase, car length, car width. So these are all numbers that are continuous in nature. So those kind of things are represented as float 64. So, and also it summarizes at the end like how many data types of float 64 existed, and so on and so forth. So this is the first thing that any data scientist does. Even with the data frame, we really want to know how many of them are there, how many columns are there, how many rows are there, and what are the data types that we have in there, and whether are there any missing data inside this, which also we will get it. But there are much more useful ways to know, there are alternative ways to know the missing values that we will see down the line. But essentially we want to review the data frame from that perspective. And also there is a possibility that there can be duplicate rows given in the data set. So we have an opportunity to look at them, review them using this method called duplicated. And then if you run this sum on top of that, it will just give you if there are any duplicate rows involved, so that we can clean them before we go ahead, we move to the next steps. But if you just don't give the sum, it is just telling us if any of those rows are duplicate. If any of them is a duplicate, you will see true against them, or maybe at least one of the duplicates will have true, and others may have false. So there are some other parameters to actually control how this is displayed. But in general, we use this method to actually understand, get to know whether there are any duplicate rows involved, right? So this is the very first analysis that we do when a data frame is actually populated from the data set. And then we will look at, in the next video, we'll look at moving a bit more deeper into the data analysis for each column, and then visualizing them. So I'll see you in the next video. Thank you.